Hey and welcome to the part 4 in this video series about Liwa Tower in Abu Dhabi. This is how far we came the last time. We moved the information about the floors, the levels and the panels from Grasshopper to Revit. In this tutorial we are going to work with the columns. The columns are following the panels. As you see here, this straight column is following the side of the panel and the diagonal columns are following the diagonal of the panels. And that's why we are going to use the grids that we generated in order to generate the panels, and the same grids we are going to use to generate the columns. And for the columns, they are quite complex. They have certain pattern that I didn't figure out. That's why we are going to make only one type of the columns. There are several types. I don't know how many, but let's say at least 3, maybe 10, I don't know. Basically, you see here, this type of the column consists only of one straight column and one diagonal column. And this type above consists also of one straight column and one diagonal column, but it's mirrored. And then there are columns that consist of one straight column and 2 diagonal columns. I think it might be this one. As I said, we are only going to work with this type. And I did some pre-studies. First I show you how not to make the family. Let me open my pre-studies and let me open my family, column family. Basically what I did, I used structural column template. I aligned the straight column along this central line and then I attached diagonal column to the straight one. This is the result and I will explain why it didn't work. It worked only for the lower floors, but then it rotated in a strange way, but there is an explanation why this family aligned the way it did. If we go to Rhino and Grasshopper, open Rhino, open Grasshopper, and open my pre-study file. I think that's this one. Let's see what's going on Rhino screen. Now we can see the columns even in Rhino. As I said, it aligned nicely at the lower parts of the building, but then it started rotating. And as I said, there is explanation for that, and that's, yes, here. Basically, you see, we can take these 2 columns. This straight column is aligning along this line, that's this vertical one, but this diagonal column is aligning according to this line's horizontal plane, and this line's horizontal plane is not the same as XY plane, and this diagonal column, you can see it's aligning along this line's horizontal plane's y-axis, and you can see it here also. At the higher levels, all these columns are aligning along y-axis, and the distance is correct, but the orientation is not correct. That's because Revit is aligning this column along this central axis, and this column is aligning according to this central axis y direction, so to speak. That's why we cannot make a block with 2 columns. We need to move each column from Grasshopper to Revit separately. Only one column in one family. Now I opened the file that worked, and in this file I moved the vertical columns and the diagonal columns separately. And the vertical columns I call C1 and the diagonal columns I call D1. As I said in the beginning, in order to generate the columns, we are going to use the same information to generate the panels, since the columns follow the form of the panels, as you see in this photo. You see here that we did some calculations, and that's because when we are moving the information from Grasshopper and Rhino to Revit, we are doing that through parametric families in Revit. And parametric families in Revit have their own logics and their own constraints, and they do not follow the logics of Grasshopper and Rhino. That's why we need to do some adjustments in order for columns to align properly, for instance, to the floor levels. I will show you what I mean. Let's go to the east view, and here I have my columns, and they go from the middle of the floor to the middle of the floor. This is my diagonal column. Select all instances visible in view and hide. Now you see this column is going from the middle of the floor to the middle of the floor. Here we see that as well, and that's why we need to do some adjustments. And let's go and do everything together. I will erase all the information one column at a time, otherwise Revit is going to crash. Delete. Okay, delete the diagonal column. Okay, we will delete this as well. Do everything together. Let's go to the 3 view and erase all the columns that are not tracked anymore. Select all instances visible in view. They are unpinned, and now we can delete them and choose all diagonal columns visible in view and delete. And I will even delete all my families, structural column families. Here, delete, delete. And now I have my original grid, and I will extract these points from my original grid because we are only going to work with this side of the surface. And here is my original grid, and we are going to go to the paneling tools menu and grid utility and subgrid. Grid to grid, and I already did this before. For x0 we are going to have 4. For the y0 we are going to have in this value 0. For x1 we are going to have in this value 5. And for the y1 value we are going to have in this value 19. Now we extracted the points that we are going to work with. I will group this and move at the lower part of the canvas here. And basically what we did, these are in these values 0, 1, 2, 3, 4 and 5. So for the x value we have from 4 to 5, and the indices for these vertical directions are going from 0 to 19, and we need them all. Well, basically, let me turn off the previous grid. Preview. This will be nice. And now I'm going to extract the points I need for my columns. I need 3 points. And I can take this on copy. Here I will have in this value 0. That's the first point of my diagonal. I will have it down here. The next point is going to be this one, and that one has index value 1, I think, and the next point has the index value 2, 3. And now I go to my curve menu and create the lines. And this one is going to be from 0 to 3. No, this will be 2. No, actually we can't do that. We need to cellulate the grid before we extrude the points. And we go to the paneling tools, and here is the cellulate grid component. And here we have wires, cells and meshes. I will take meshes and go to mesh menu and deconstruct mesh and connect meshes to this deconstruct mesh component. It works in the same way as this deconstruct wrap component. And now I can go to my item components. Let me take this panel. This is going to be in this value 0. That's this one. The next one is going to be in this value 2. Make a line from 0 to 2. This one is going to be 1. Yeah, that's correct. And the vertical line is from the index value 1 to the index value 2. That's correct. Let me bring the scribble. Call this vertical line. Okay, group. and this one is going to be diagonal and group. So I'm going to use these lines to generate the columns. Let's go to structural column family, new family, English metric, structural column, open. Now let's do something. It doesn't want to save. Circle. The diameter of round steel columns varies between, I don't remember, I think between 7 and 30 centimeters. So let's have 140. I will make a parameter, and this one I'm going to call diameter, and it's going to be type parameter. Okay. Let me save the family first. Save. I will call it C, save. Let's edit the profile and make a new circle, and this one is going to be smaller, and I will make a parameter for this one as well. I call this one diameter 1, and it's also going to be a type parameter. Okay, okay, and now I'm going to my family types properties. And the depth is going to be the same as the diameter, and the same for the width. And then I will add a new parameter that's called thickness, also the type parameter. And the thickness is going to be, let's say, 10. The thickness of the steel columns varies between 7 and 13 millimeters, I think. The diameter 1, I'm going to have a calculated parameter. It's going to be diameter parameter space minus space thickness. Okay, and let's see. Yes, because we want to control the thickness of the column and the diameter of the column. Let's go to the front view. I will extrude this column a little bit. The extrusion is going to have its own parameter, and that's going to be on the instance level. I will call that parameter C center line length. Okay, okay, and now I have my column. I can load it into the project, save and load into project. And let's see, it's this one, cancel. And let's go to Grasshopper and to the Revit menu, structural, and add structural column. And I will connect this vertical line to the curve in the structural column, and the type is going to be C. Then I'm going to bring element parameter component and connect this column to the input value, element input value. I want the length of the column. The length of the column is going to be C center line length. That's what we call it in our family, and I will connect it to the P input value, to the parameter input value, and the length is the length of this vertical line. To start with, we go to curve, analysis, and length here. Now it's longer, and let's see what's going on the screen. And these are our columns. Let's go to the east view. And you see now, it is going from the middle of the floor to the middle of the floor, and that's how it's supposed to be. But this bottom part is not aligning, and it is supposed to align to be parallel with the floor plane. We are going to make a void in our family, and we need the angle between this floor plane and this column, and that's what we are going to calculate. Let's see. We will first make the void in our family. Go to the front view, and I already did this, so we are going to make the void in the left view. We will start with the extrusion, not with the void extrusion, but the solid extrusion. The void looks like this. And we also have a void at the bottom. Let's see. Correct. And now I need some parameters for the void, and Why is it grayed out? We go to this lower reference plane and this point. And now we have a dimension that we can use to make the parameter. This and this. And the same here. And let's define some dimensions, a parameter for C. It's going to be on the instance level and we will call it C void angle. Okay, and even this one. It's already defined, we only choose it. This length needs to be the same length as this one. Revit is full of constraints. Let me make a new void. I will call this one C void angle top. Okay, okay, and then I will call this one C void angle bottom. I will erase these. Let's start like this, and probably we are going to come back and adjust the family if we need to. But let's start like this. And now I will change this solid to void, and I will cut this column with my voids. Let's save the family and load into project. Overwrite the existing version. And now we need to define where this void is going to cut. Let's go back to our family. I will change this. I will uncut geometry, this and this. And then I will change this void to solid in order to continue working with the parameters. Edit extrusion. And now we need to define where the void is going to cut. From this lower reference level to this point. We say that the void is going to cut at the top of the column, and that is the length of the center line. Now I think it will do. Change the solid to void and cut. Cut geometry, save, and load into project. It looks better, but now we need this angle. Let's see here what we have. We have the line, and we can generate horizontal frames in, let's say, in the start. Like this. At the start, at the bottom of the line, and then we can choose only one. That's going to be the one at the bottom, and then we will check angle between x-axis and this line. And we go to vectors, angle, and that's going to be angle between the vertical line and the x-axis of the horizontal plane. And we need to find the x-axis of the horizontal plane. That's why we will deconstruct the plane. And here is the x-axis, and here is our angle. Let's see. So this is my angle parameter. Go to Revit and element parameter. Element is the column. The name of the parameter, let's see. Let's check the name of the parameter. C void angle top. C void angle top. Okay. That's the name of the parameter. And the value is this angle, and let's see if it's aligning. No, it doesn't. Base sketch for the extrusion is invalid. Let's go to our family. I will delete the extrusion. I will start from the beginning. Create extrusion. Extrusion is something like this. And let's see, this is the angle I need, and it's already defined. This is going to be the top angle, and basically I want this upper part to be equal to the length of the column. So from this lower reference level to this point is going to be the length of the center line. Okay, save and load in the project, and element parameter. Let's see if it works now. And now it works. You see, if I hide this one, hide element. Yes, exactly, we didn't cut, but the parameter is working. Let's go back to the family, and this is going to be void, and I will cut it. Let's go to the front and see, make it a little bit bigger. Now it's cut. Save and load into project. And it works now, you see. This top is parallel to the floor level. And let's do the same thing for the bottom. And for the bottom, I need to uncut again. I will change the void to solid in order to be able to define parameters. Edit extrusion. And I will do the same thing for the bottom part of the column. This and this. And then I will choose this line and align it with the lower reference level. Then I will define the angle for this. Call it angle bottom. Save. I will also change it to void and cut the geometry. Save again and load into project. Copy this. And this one, I change the name from top to bottom. And it's the same value anyway. So see, now this bottom part is also parallel to the floors, but the column is too short. The length of the central line is too short. We have to calculate that, and now I will explain how. You see here, the center line is going from top to bottom, and since the column is tilted, we are going to miss x value at the top and the x value at the bottom, and that's what we are going to calculate, and then extend the length of the column with 2x. And let's do that together. For the x, we have this length. This length is half of the diameter of the column. Let's go to element. Instead of checking the diameter of the column, writing it manually, we can extract it with this element parameter component. And let's go to primitives and type. And I will change the type to structural columns. C. Connect it here. The name of the parameter is diameter. And now we have the value of the diameter, but we need half of this diameter. And we can go to math and division, value divided by 2. It's 140. So if we would change the diameter or the type of the column, then this value will follow. Now we are going to math again, and we will bring this component. And the diameter is going to be, I think, P, that's this one. And we have this angle, and this angle is 90 degrees minus, let's see, 90 degrees minus this angle, the angle between the central line and the horizontal plane. And let's see if we can store that value. We will store it in this, that's not integer, that's number. And I will call it angle. As I said, the angle, this alpha value is going to be 90 minus this angle. 90, we are working in radians. 90 is equal to P divided by 2. P in radians is equal to 180, and P divided by 2 is 90. Let's go to math. P divided by 2. I already have 2 here. And then we need minus as well. And that's our angle. Our X is going to be this Q output value. And let's read the value. Yeah, it varies between 23 and 8 millimeters, 5 millimeters. And it's going to be this length multiplied by 2, because we miss X both at the bottom and at the top of the column. And 2 again, I have that here. And the value is going to be, yeah, between 16 and 50 approximately. I delete this. Let's see. The length is here, so we are going to have a new length. That's this value plus the length of the line. And this is the new length of the central line. This is a little bit too high, and the lower one is a little bit too low. But let me see others. Here it looks good actually. I'm happy with this. So this is our vertical column, and instead of all these calculations here, there are too many components. Instead of all of this, we can bring the expression component, P divided by 2. Let's see, angle, I'm going to connect the Y input value minus Y, okay? And for the Y, I will have this, and let's see if we are going to have the same result. These are the results. That's the same values. We will exchange this. We don't need. Let's leave it there. This is our C column. Group, scribble, C. So that's how you move these vertical columns from Grasshopper to Revit. All these adjustments that we made, we did that because the logics of Rhino and Grasshopper geometry is not the same as the logics of parametric families in Revit. That's all for now. This tutorial is getting too long, and I don't like long tutorials. That's why I'm going to make a new video for the diagonal columns. So thank you for watching.